Important questions on electrochemistry. The first question is the SB203 is an example of blank space is there, and then electrode means we have to fill up the blank space out of the four options provided here. A gas, B a pH indicator, C a redox electrode, D a first kind electrode. So this needs a little consideration where we can very easily find out that it is a redox electrode. SB203 is an example of a redox electrode. Why? The explanation is here. The redox electrode, in this type of electrode, there is a reversible oxidation reduction, or what we can say redox reaction at the electrode surface. The SbSb2O3, that is antimony and antimony trioxide, can be oxidized to antimony trioxide and vice versa. So it depends upon the conditions. This redox reaction is the basis of electrochemical behavior. And of course, it occurs at the surface of the electrode. And then there are other options provided. We should consider why they are not the correct answers. pH indicator represents change in color with response to change in pH. This doesn't happen. So a gas electrode involves H2H plus, that is hydrogen electrode. So that cannot be the right answer out of the options given here. SbSb2O3 electrode does not involve a gas phase in its primary reaction. And first kind electrode is nothing but where there is a direct equilibrium of metal with the ions in solutions, that is Cu dipped in copper sulfate solution or copper ion solution, cuprous ion solution, or cupric ion solution. Actually, it is cupric ion solution. Then there is another question. The question is very simple. And here, standard electrode potentials of different cells are provided here. Mg2 positive Mg is minus 2.37 volts. Zn2 positive Zn is minus 76 volts. Fe2 plus Fe is minus 4.44 volts. So, which is the correct statement? Four options are given, and we have to find out whether zinc oxidizes iron, or zinc reduces magnesium, or magnesium oxidizes ferrous ion, or magnesium reduces zinc dipositive ion. So actually what happens, which has got the least electrode potential is less reactive, whereas compared to the one which is having a more negative electrode potential. And accordingly, if we find the correct statement about the oxidation and reduction of Mg, Zn, and Rn is based upon their standard reduction potential, and therefore we need to compare which metal will reduce the other metal. And in this case, we have to understand that more negative reduction potential indicates stronger reducing agent. A reducing agent causes another substance to be reduced and is itself oxidized. Very obvious. A substance which more negative reduction potential will reduce a substance with less negative reduction potential. So these are some of the points which are being provided to you for your reference. And of course, these are very important aspects are the points to be considered. Now, considering the electrode potentials given here, we can find out that magnesium can reduce both zinc and iron, Zn2 positive and Fe2 positive ion. And zinc can reduce Fe2 positive, but not the Mg2 positive, that is magnesium ion. Ferrous iron cannot reduce Mg2 plus Rz ion because it is least electronegative. Therefore, the correct statement is that magnesium reduces Zn2 positive, and that is the right answer. So accordingly, we find that here option D, that is magnesium reduces Zn2 positive, is the correct answer. Okay, thank you. Please do subscribe to our channel. Thank you again.